Oh hey, didn't see you there. Today is the refactoring episode where I will be uncooking the spaghetti in my engine. We will need to do this before starting to implement the upcoming features. Without further ado, let us begin. Most of you are already aware how C++ code is converted into an executable file like a game, for example. But let's go over it in case you don't. At the start, we have our C++ code, and the final goal is an executable file we can run. This process involves several steps that I will summarize in short. First step is preprocessing, where things like define or include are processed. For example, at this point, the header code is included into the source files. Second step is compilation, where C++ code is converted into assembly language. This step succeeds only if it doesn't have any syntax mistakes. Compilers also may optimize your code during this conversion. Third step is assembly. Assembly language code is passed to the assembler, which turns it into machine language instructions. These instructions can be understood by the processor. Fourth and final step is linking. Previous assembly stage produces multiple object files that the processor can understand, but by themselves these files cannot be run. Linker combines these files into a single executable file. If external libraries are used, the linker also resolves all references needed for the program to access them. Thankfully, all of this complicated work is currently done by Visual Studio. We set up the project settings and just click the play button for the code to magically turn into an application, but even that is not good enough for me. Let's look at our game engine. All of our code is located inside a single Visual Studio project, and all of that code is included inside the final application, whether we need it or not, and we do not have any way to control what gets included. With enough code, this will increase the size of the application and its memory usage. That's the first problem. And it could be resolved with Visual Studio by creating and managing multiple projects, but the same thing cannot be said for the second problem. Let's talk about build configurations for a bit. You may have heard of terms debug and release, for example. Shortly explained, debug builds usually include some sort of additional checks to make sure the application is running safely. An example of this is checking if memory out of bounds is being accessed. The operating system might not care if the memory touched is unused, but it also could result in a crash if it was used, because the operating system will chop your application's fingers off if it tries to access memory that is already in use. Debug builds allow us to enforce strict rules for these types of things, so we can make sure that they do not happen in production. But having them in the final application would make it slower, so we put them in another configuration. This is just an example of what it could be. Anyway, the reason I am talking about this is that some libraries have different implementations for debug and release configurations, and so will our engine. We need to specify this in the Visual Studio settings. Visual Studio works in a way where you manually link all libraries for each configuration. Let's say you want a new library. You would go through each config settings, like debug and release for example, add the files and adjust the linker settings manually. We are going to ditch Visual Studio in this process and instead are going to use a different build system. C++ has countless build systems available, but we will need to make a choice nonetheless. I knew this problem with my project for a while now, and coincidentally stumbled upon a video from Cherno where he talks about the very problems I was experiencing. Link to his video in the description. So what will we be using for building our project? I could go into an in-depth analysis of each build system and come to some sort of rational solution, however, I will keep this simple. I was mainly choosing between CMake and Premake because of their popularity. My final choice was based on two factors. The first factor was if I had any knowledge of that system. The answer was no for both of them. The second one was which was more simple to use, and the answer was Premake. I think for my game engine, something that is simple is the best option for now. Luckily, Cherno also provided his own Premake template with his video, so let's take a look. The link to his template will also be in the description. The template follows a core app logic. Basically, the core is a static library, and the app is an application that references that library. The system can be extended, but for starters, the core would include the window creation and management, graphics device management, entity component system, rendering systems, etc. The most low-level code that will be required for anything we want to create. The app part would be the editor. The editor would have code that involves world editing, saving, and loading, and the UI to edit these worlds. This code has nothing to do with the core, and it will not be running inside the core. In the future, we will likely need even more separation to have an even more modular approach, since the editor might have parts that overlap with what the games need to have. But let's not get ahead of ourselves and just focus on making the first separation. You may see that we will still be using Visual Studio. That's because the build system automatically creates files for Visual Studio for our convenience. But even when launching the application, in the background, pre-make commands are being executed, so if someone wanted, they could still work on the code without Visual Studio. Okay, the first goal is to move the main.cpp file into the editor project and then run the project. And oh boy, this was harder than I expected. Pre-make uses a scripting language called Lua. Lua build scripts are similar to Docker files. If you don't know what Docker is, first of all, good for you. Second, it's like a checklist of what needs to be done, along with some parameters. Remember the problem with having to specify files for each configuration? Pre-make functions a bit differently, where you specify common libraries and files for each configuration in one place, and if you want to change something, you do it for that one specific configuration, instead of setting everything for each config separately. Anyway, after like 5 hours, I finally spaghettified the Lua build files enough to make the engine run again. Great! Now we will have to make the code separation, and this part was, I don't even want to talk about it, but for educational purposes, let's see what I came up with. So the main challenge with separating the core code from the editor code is that the core does not have any knowledge that the editor exists. Things like game loops always run in the core, and in our case, universe class that manages the worlds cannot be placed inside of that loop. The core has no idea what universe even is, because the editor is a completely separate project and the core does not depend on it. Think of the core as the engine of the car, and the transmission, steering wheel, etc. as the editor. So how did my poor brain solve this task? Well, first, I created an interface called engine module in the core. The idea is that applications like the editor can utilize this interface so that the core can invoke render and update loops, for example. This was a good idea. We just need to solve a little issue of setting references to the window and graphics device in the universe from the core, which, let me remind you, has no idea that this code even exists. I will not go into a lot of detail of the absolutely ridiculous stuff I started to do. All I have to say is that it took me almost 10 hours, and that the whole reason that I tried to engineer this abomination is that there was a bit of a problem with how the application is initialized in my code, and I could not retrieve the needed references for the universe before giving its control to the core via the engine module interface. Technically, application-level code is not my code, as I started the project from a template called LearnD3D11. Link in the description. It's a good learning project if you are looking for a place to start. Anyway, I just blatantly copy-pasted it into my project, and I have been avoiding to edit it since I did not understand most of the things that were done here. But the time has come. I changed a bit how the application is initialized and was able to retrieve the references to the window and the graphics devices prior to starting the editor. This now meant that the code that took me 10 hours to write is no longer needed. So what did I do with it? I burned it like the trash it was. Was I wrong to do it? Let me know in the comments. With this conundrum resolved, I could move the editor code outside of the core, and the only thing left to do was to fix this ugly main function. So naturally, I just created another class for this ugly mess and pasted it there. Guess we will be calling this our editor from now on. In the future, we will definitely need to change the structure further, but I gave myself the pleasure to introduce you, the viewers, to the tools I will use in the background. And now, let's plan the fun stuff that is about to come. Features! I took my time to resolve the not-so-fun problems, and now we will finally be able to work on the fun things. The first feature I will be working on is terrain. I will go with something simple, but we will need a playground to test lighting, physics, player controllers, noise generation, etc. I think terrain is the perfect tool to start on first. For the absolute beasts that stuck with me to the end, thank you. Hopefully you enjoyed the video and maybe even learned something new. I'll be seeing you again. Have a nice day.